Here's our user class. The user class is going to provide the application the ability to create objects of type user. Every object that gets created of type user will have its own copy of the code within the class user. So we begin the definition on line 4 with the keyword class, followed by the name of the class. All of the code that belongs to this class is enclosed within opening and closing braces. The first thing we see inside of the class definition is the attributes for the class: username, preferred email, secondary email, user ID, and status. All of these are marked as private, which means that no one who uses the class will have access to these attributes. Because of the private keyword, these attributes, these variables within the class definition, are not accessible to the public, to any user of the class. On line 14, we define the function construct. Again, it's 2 underscores and the word construct. This function defines the process to be used for creating objects of type user. On line 14, notice that the construct function is declared as public, required. It must be declared as public so that anyone that wants to create an object of type user can do so by causing the call to the construct function. Inside the construct function, we take the arguments that are passed in and assign them to the attributes. So the construct method takes 3 arguments: a username, a preferred email, and a secondary email. Now notice that the secondary email has a default value. So someone creating an object of type user could pass 2 arguments into the call to create the object. They could pass username and simply 1 email because the second email will default to null. This provides some flexibility for the user. In any case, all of the attributes of the object are initialized. They're given initial values within the construct function. Note how the attributes are accessed within the class functions. We use the $, this variable, the arrow operator, and the name of the attribute. Notice that the name of the attribute does not use the $. The $, this variable, is a built-in variable that's provided to us by PHP for every object that we create. This points to itself. It is a handle to itself. Hence, we use it to access the internal attributes of the object. The syntax can be a little tricky, especially remembering not to put the $, before the attribute variable names. So pay particular attention to this. The next function on line 24 is the destruct function. Again, underscore underscore destruct. This function is called by the PHP preprocessor whenever an object is no longer needed in the system. In our case, we have no resources to release, so we're just echoing a statement identifying the object that's being destroyed. Again, these functions are all declared as public, which means that anyone can call them. Next, starting on line 29, we have a set of get functions. Now, this is typically the interface that's provided to allow someone using this class to access the internal attributes of the class. Again, a reminder, we don't ever want to give direct access to the attributes to any user. We cannot protect the state of the object if a user has direct access to the attributes. So we have get functions for username that simply returns the value of username. And again, pay particular attention to the mechanics for accessing the internal attribute from within the object. This arrow operator and the attribute name. We repeat this process for the preferred email and the secondary email and the user ID. And all of these functions just simply return the internal attribute's value to a user of the object. Now, we've decided in the design process that there is no need to provide set functions for the username or the preferred email or the secondary email, and certainly not for the user ID, because these are values that are set during the construction of the object and should not be changed thereafter. An argument could be made that you could provide a function to update the preferred email or the secondary email. I'll leave that to you. However, there is no need to update the value of user ID or to change the value of username. So the only set function that we provide is for the user status. We allow a user of our class to set the user status. Now again, we are responsible for providing an interface to our object that protects the state of the object. So you should never write a set function that accepts input from a user of an object without validating the values that are passed in by the user, again, to protect the state of the object. In this case, the only valid inputs for set user status are either 0 or 1. So the first thing we do on line 58 is we test that input. The input must be 1 or it must be 0. It can be nothing else. And if it is, we return false and do not change the status of the object. If the value is 0 or 1, then on line 62, using the this variable pointing to ourselves and the arrow operator, we access the attribute status and we assign the input value to that attribute. Then we return true to the caller. The key to creating a class is on line 4, the keyword class followed by a name. Everything gets enclosed in opening and closing braces, and everything within the class definition must be adorned with either private, public, or protected. Then we must define a construct function so that we can control the creation of an object of this type. The construct function will ensure that the object is created in a valid state. The destruct function is optional. We are not required to define a destruct function. However, it's good practice to take control of the destruction process of our objects. Whether or not there are resources to be released, we want to keep control of our object. So let's look at our helper function. We're calling the helper function on line 20 to return to our constructor a user ID. Now the user ID must be unique in the system so that every user has a unique user ID. So let's look at this helper function and how we achieve that. Very simple function. Function getNextUserID takes no arguments, declares a static variable initialized to the value 1. Remember that the static keyword says that this variable will live throughout the calls to this function. So it has a lifespan across calls to this function. And then we increment the value of user ID by 1 after we send the value back to the caller of the function. So in this call on line 20, we will always get an incremented value for the user ID, ensuring that our user IDs are always unique. So let's see how we can create now one of these user class objects. Well, the first thing I do is I require the inclusion of the userClass.php file on line 8. And that's a cascading inclusion because when I include the userClass.php, it will include the helpers function itself. So now I'm going to create a new user on line 10. I create a variable called Picard, and I say assign to Picard the handle for a new user object. And here are the values that I want you to use to construct that object. Then on line 12, I simply echo the values within that object. On line 16, I create a second object and I assign the handle to that second object to the variable Ripley. When I create this object, I am passing in 3 values to the construct function. Now, I don't call construct. It is called for me. That's managed for me by the PHP preprocessor. The syntax is for me to use the new keyword and the name of the class from which I want to create an object. Within the parentheses following the class name, I pass the values that the PHP preprocessor will pass to the construct method. Again, I don't directly call construct. The PHP preprocessor does that for me. On line 17, I do a print R to dump the contents of the Ripley variable, which will be a handle to a user object. And then, simply to demonstrate another function we can use to see the contents of an object, on line 19, I call var dump and pass the Ripley variable into that function call. So let's see how this works. So we'll see the output from our collection of echo statements on line 12 through 15. Then on line 17, I call print R on the Ripley object. And similarly on line 19, where I call var dump, I get a dump of the contents of the user object. And notice that the information provided by var dump is more detailed than what's provided by the print R. And then finally, the last 2 lines output are from the destruct method. Recall that in the destruct method of our user class, we said, when you get called, when this function gets called, print the username associated with the object, this, whatever the current object is, print the username and object is being destroyed. So what we see is that both the eRipley and the JPicard objects are automatically destroyed for us when the application terminates.